Corporate finance practice problem using Excel, present value with a planning scenario. Don't leave profits solely to chance. Instead, use corporate finance. Here we are in our Excel worksheet. If you're following along with the Excel worksheet, we're in the Practice 1 tab. Note that there are 4 practice tabs and there's 4 example tabs. So you can take a look at the completed example and then work through the practice problem in the practice tab. Also note that we're going to be looking at the present value of 1 type problems and then present value of an annuity type problem. So the first 2, present value of 1, second 2, present value of an annuity. We'll be calculating those in a few different ways, including a mathematical formula, Excel formula, and with the use of tables. So present value, how much must you invest to get? So if we're thinking about getting something in the future, we have the 15,000. So how much must we invest to get up to then that 15,000 in 9 years at a rate of the 12%? So in order to do that, what we're going to do is basically present value the information of the end point. So we're imagining at the end, we're going to have the end point, the future value of the 15,000, and how much do we have to put in now as a lump sum with the rate at the 12% to get up to that 15,000. So we're going to figure that. We say, okay, well, that's kind of a present value of 1 type of problem. So I'm going to take that 15,000 and see if I can bring it back to today's dollars, which is going to be bringing it back 9 years. Then we have to come up with the discount rate or the rate of 12%. Again, you can use multiple methods to do that. That's going to be some type of estimate to take that into consideration. Once we have it, we can apply our mathematical formula, or we can use one of our other methods in order to calculate this. Let's do it first with the mathematical formula, which is going to be the future value times 1 over 1 plus r to the n. I'm going to break that out into basically a vertical type of format, so we can break this down in this format. You can do it algebraically, of course, in a kind of standard algebraic written way as well. So I'm going to take the future value, I'm going to put that in the outer column. That's going to be the 15,000. Then we're going to be taking our 1 plus r to the n. So 1 plus r to the n. So I'm going to bring that into the inner column here. And it's going to be 1 plus the rate, I'm going to say is equal to, I'm going to say equal to the 12%. Then I'm going to add those up. This equals the 1 plus the 12%. I'm going to make these percentified in cells. I'm going to select those cells, go to the Home tab, the numbers, and percentify them. So there we have 12 and 112. I'm going to underline here, Home tab, font group, and underline. And then the number of the periods, we got to take it to the number of the periods, which is going to be 9 years. We are talking about years here instead of months. So then I'm going to pull this answer out to the right-hand side. Let's go ahead and Home tab, font group, underline this one. Pulling this out to the right-hand side, this will be the 112. And then to take it, it's a caret in a computer. So we're looking Shift 6, caret to 9, and enter. I'm going to add some decimals. So I'm going to go Home tab, numbers group, add some decimals. So we can see that that is really a much longer number than we can see without the decimals. And then we have the present value calculation, which is then going to be equal to the 15,000 divided by the that number, the 2.773, and so on. And let's go ahead and put an underline here. And so we've got, and let's add a couple decimals to this one. Home tab, numbers, add a couple decimals. There we have it. So we'd have to put the 5,409.15 in today in order to get the 15,000 of future value. So notice we kind of backed into that. We said, where do we want to be at the end of this thing? 15,000 future value. Brought that back to the present, thought about what we would need to put in a 1 lump sum kind of situation. What would be the rate if we were going to construct the table down here for our present value table? It would be equal to this 5,409.15 divided by the 15,000. And let's add some decimals. Home tab, numbers, and add some decimals. So when we go to the tables, we'll kind of compare that out to the tables. Let's do this with a present value formula. I'm just going to do the formula this time. Remember that you can go up top to the formulas up top and use your little formula box here. But I want to practice just entering the formula. These present value and future value formulas are quite common. So we want to be able to just basically enter these in. So I'm going to say present value, and then I'm going to double click the formula. Then I'm going to use this little thing down here to help me out. So it says rate is first. So I'm going to say the rate is 12. This is per year, so I don't have to divide it by 12 or anything to get the monthly rate. Remember that if you do have a monthly rate, you do have to do that. Number of periods is going to be 9. We are talking in terms of years as opposed to months once again. And then the payment amount that we're going to have, and I'm going to say is 0. So we can either put a 0 there or 2 commas because we're talking about not an annuity and therefore nothing there, but rather the present value of 1. So we need to bring in the future value, which we said was this 15,000. Shift 0, closing up the brackets, and there it is. And same number there, done magically, just magic. And then I'm going to double click on it and go to the front of it. I'm going to put a negative just to flip the sign to it. And that makes it positive, basically saying times -1. Let's do that once again with our tables now. I'm going to delete this so we can enter it again. So this is going to be equal to the amount of the 15,000. We'll pull our information from the tables this time. And we're looking 9 years and 12%. So 12% and 9 years is going to be this 0.3909, 0.3909, 0.3909, 0.3909. And then I'm adding some decimals, home tab, and numbers group, add some decimals, and then let's go ahead and calculate. This is going to be equal to the 15,000 times that. That gives us this number. Let's go ahead and add decimals there. Home tab, numbers, add a couple decimals. Let's put an underline here. Home tab, font group, and underline. It's close, not quite the same. It's not even close. What happened? Hold on a second. This is 9 years. 9 years at 12%, and 9 years, 0.3606, and I put 9s in there, 0.3606. Okay, that looks better. It looked right to me with the 9s, but that's fine. That's because that's me. So I got the 5409. Now it's close, not exact, because there's rounding. So remember, we looked at the table last time. We calculated the table out to more digits, 3606. And it's really 3606 if rounded to 4 digits, so it's a rounding issue. Let's do it again before we go to the annuities. We'll do it a little bit quicker. Go into the practice tab 2 this time. Same kind of process in practice tab 2. We're going to do the same scenario. How much must you invest to get 20,000 in 17 years at a discount rate of the 7% now? So now we're thinking we want to be at 20,000 in 17 years because we're going to do something with that 20,000 at that point in time. And how much do we have to put in like now, one lump sum for it to just grow? And we could just leave it alone to get to that future point. Well, let's take up the 20,000 being the future value. We're looking at it in terms of the mathematical formula, breaking that formula out into basically an Excel type of table worksheet here. So we got the 20,000 up top. Then I'm looking at the 1 plus r to the n. So I'm going to pull that to the inside. I'm going to say 1. Let's just make this 1 plus the rate, which is going to be the 7%. I'm going to percentify that. Home tab, number group, percentify, and underline. Home tab, font group, underline. Then add it up. This equals this plus that. That's going to give us 107% once percentified by going to the home tab, number, percentify it. Then we're going to take that to the number of periods, in this case years, that being 17 years. 17 years. I'm going to pull this over to the outside because we've completed this whole component down here. This is going to be equal to the 107 times, to the power, which is shift 6 caret to the power of 17. And then I'm going to add some decimals, home tab, number group, decimals. There we have that. And then we've got our present value calculation being equal to the 20,000 divided by this item. Notice if I multiply this out, it's kind of future value over the 1 plus r to the n. So here's the numerator and denominator in our table that we broke out here. Everything else on the inside. That's kind of how we're working our tables. Useful to put things into tables like this. You can practice making like a tax return type of format, and can help you to think things out, I believe. So I'm going to then go and add some underlines here. We're going to then see what if I calculated the rate here for the table, this divided by the 20,000, adding some decimals like home tab, number group, add some decimals there. That's what we expect to see on the table, but the table's only going to be out to 4 digits, whereas we calculated it out further than that. Let's put some decimals here too. Home tab, number, add decimals. So that looks good. Let's do it with a formulae now for Excel. This is going to be equal to present value, and I'm gonna make this a little bit larger here, just so that'd be a little bit easier to see. A little bit larger. So I'm going to say this is going to be equal to present value. This time I'm going to say shift 9. We need the rate first because that's what the little dialog box says. So rate is here. We're doing the yearly rate, so I don't have to divide it by 12 for a monthly rate or anything like that. It then wants the number of periods, which we discussed is in years, 17. So we don't have to divide it by 12 or anything, or multiply it by, or do anything to make it a month. And then we have the payment. The payment is going to be nothing, 0, or simply another comma, because we're not talking about an annuity, but rather talking about a power of 1. So we're going to say the 20,000 and enter. I don't even need to close it up because Excel won't even give me an error thing if I do that. Then I'm going to flip the sign by double clicking on it, putting a negative before the P, multiplying it times -1, flipping the sign. We get to the same answer once again. Magic. Then we're going to go over here and say that we'll start at the 20,000. Again, now use the tables this time. Tables, we want the 17 years at 7%. 17.7. 7%, and then like 17 years is going to be the 0.3166. They're not nines. 0.3166. 0.3166. 0.3166. Adding decimals. Home tab. Numbers. Decimals, multiplying equals 20,000 times that decimal. We get the 6332. Adding decimals, home tab, number, add a couple decimals. It's not quite the same because there are rounding. This is what we came to, and they rounded it to 4 digits, which is not quite as exact as what we did. Home tab, font group, number, but good enough for practice purposes, or for decision making in general. Let's go to practice problem 3, which is going to be slightly different this time. We're breaking things out, switching things up. We got the present value. We want then the how much must you invest to get each period. So now we want each period like an annuity. We want to get paid $8,000 each period. Once again, we're kind of thinking about where we want to go, which is 8,000 each period, and we want to look at that in terms of an annuity and say, okay, what if we had an annuity of 8,000 for 15 years at the rate that we came to of 11%? How much would that be in present value dollars? And then we can think about if we put that present value amount in, then that's how much we would need in order to receive the 8,000 periodically. So same kind of thing. It's a little bit more tricky to mull over, however, I believe, with this annuity type of payment. We're going to take our formula down here, which is going to be the payment, and then we got to multiply this times 1 minus 1 plus I, which is going to be the rate to the negative n divided by I. So we could do this by writing it down algebraically. I'm gonna try to break that into a table once again, and what I want to do is basically get to this C times something, right? And then in an inner column, I'd like to have the numerator and denominator basically broken out in the inner column. So I'm imagining then in the outer column, I'm going to have C times this. That's kind of like the external equation that we have here. So I'm going to say the payment is going to be C. We're going to say this is going to be 8,000. And then I'm going to take a look at the amount that's going to be 1. We got 1 minus all of this stuff happening. I'm going to put that in the inter column here. I'm going to put that in column F, and I'm just going to put my 1 here. And then I'm going to put this whole thing, the 1 plus I to the negative n, in the inter column. So that's going to be the 1 plus I to the negative n. So I'm going to start with 1. I'll put that in the inner column, or just type in 1. And then our rate is going to be that 11%. Percentify it, home tab, numbers, percentify, underline, home tab, font group, underline. Adding those up, this is going to be the 1 plus the 11%, giving us 111%. If we go to the home tab, numbers, and percentify it, Then we're going to take that to the power of the number of periods, in this case years, that being 15 years. Underline that. I'm going to go Home tab and font group and underline that. Then I'm going to pull that answer into the outer column so that then I have the 1 up top, 1 minus this to the power of n. And then I'll do that subcalculation in this table in this column. So I'm going to say this is going to be equal to the 111% to the power shift 6 of 15. Then I'm going to add some decimals, Home tab, numbers, add some decimals. So there we have that. And then I'm going to take the 1 minus this thing that we just figured out. We just figured this out and we got the 1 minus. I'm going to pull that into the outer column. So I'm going to go Home tab, font group, underline. Let's pull this into the outer column. This is going to be equal to 1 minus that thing that we came to, like right there. And then we can add some decimals here. Let's go Home tab, numbers, add decimals. You could percentify it if you so choose as well. And just note, I should have taken this to the negative n. So let's make this 15. Let's make this a negative n. So now this is a positive number. And so there we have it. Okay, so then we're going to say that the rate is going to be the 11%. So then I'm going to take my rate, which is going to be the 11%. Percentify that one. Home tab, font, and underline it. And then percentify it. And then we're going to pull this out to the outer column here. And this is going to be equal to, now I've got my numerator and denominator in this inner column. So I'm going to take, this is going to be equal to then the numerator divided by the denominator. Let's percentify, or let's add some decimals. Home tab, numbers, add a few decimals there. And then we finally have, we're going to multiply it times c. So now we got this times this, which is our outer column. So this is going to be equal then to the 8,000 times this. And we made a nice little worksheet to work this out. And then Home tab, font group, underline. And this, let's add some decimals. Home tab, numbers, add some decimals. So there we have that. Now, obviously, that's a tedious way to do this particular formula. Most people will not do that. They'll use a financial calculator or something like Excel, which will do it magic-like. So we'll do the same formula for this one, even though it's an annuity. So we're going to say this is going to be present value, same starting point. We're going to say rate. This is in years. It looks much the same. We're like, this is the same thing, but we're doing an annuity. But no, it'll change here. Then we're going to say number of periods is 15. It's like, well, that's the same. But then here, this is where we entered a 0 last time, but this time, because it's an annuity, we've got the payments of the 8,000. That's where things are switched up. And then we don't have the future value because we use the payment one, making it an annuity calculation as opposed to just like a present value of 1 calculation. And there we have it. So let's go ahead and double click on it. I'm going to put a negative before the P. So we have it there again. Let's do it with a table now. We're going to say this is going to be 8,000 starting point. We got to find this amount on the table, making sure that you have the correct table, which is going to be an annuity type of table as opposed to the present value of 1. You should have bigger numbers down here because, you know, it's an annuity table. So now we're going to go down here and say that this is going to be 11% and 15 years. 11%, 15, that's going to be the 7.1909, 7.1909, 7.1909, 7.1909. Let's add some decimals. Home tab, numbers, decimals, underline it. Home tab, font, underline, multiply it out. This is the 8,000 times that amount, adding a couple decimals again. Home tab, number, decimals. So it comes out to something slightly different. Once again, I would assume that to be rounding, what should the actual number be if it wasn't rounded, or if it was rounded like to more decimals? It would be this divided by this. If we were to create the table ourselves, would be something more like 7.19087 rather than rounding it to 4 digits, and that would be more accurate. But this is good enough for decision-making purposes. Let's do it one more time. Let's do this kind of problem one more time with the annuity. So now we got the present value. How much must you invest to get each period? $60,000 for 35 years at a rate of 10%. So we want to see, once again, what we're looking for is to pull out. We want to be living on $60,000 a year, and we want to put the money in at this point, a lump sum. How much lump sum would it take for us to basically get $60,000 a year if we had the rate at the 10%? So we're going to look at our annuity table and kind of think about, all right, well, if I had an annuity thing and I was putting $60,000 in for, 35 years at 10%, what would be the present value of it? And that present value then is what you would think that if you put it in at this point in time, you can then, pick the 60,000 up. So that we're going to do this the same kind of thing, one with a mathematical equation we'll do down here, and then the way you probably do it more often, which is in Excel or the use of a table. So we're going to do this again. We're going to put these two items on the outer column, kind of build like a tax return type of table with it. And then we'll calculate the numerator and denominator, put that in the inner column here, and any other calculations inside. So let's do this again. I'm going to say this is going to be the 60,000 in the outside, because that's going to be like C, or the payments that we expect. Then I'm going to look at the number 1, because I'm going to cut this one out into 2 components. So I'm going to pull that in the inside. I want the numerator and the denominator in G here. So I'm going to pull this part into the inside, and I'm going to pull this one into its own little section. So I'm going to say first I want 1, and it's going to be 1 minus this, 1 plus I to the n, which I'm going to pull in here, 1 plus I to the negative n. So I'm going to say this is going to be 1. The rate is going to be the interest rate 10%. I'm going to percentify that, home tab numbers, percentify it. Then underline it, home tab font, underline, and then add it. This is going to just use the sum function this time, equals the sum of those two. Percentify that, home tab, numbers group, percentify 110% to the power of 35 years, that being the number of periods in years. Be careful if it were in months or something like that, but we're in years at this point. And that should be a negative, because it's to negative n. To negative n, and then I'm going to multiply that out. That'll be this component, and then I'm going to subtract the 1 minus it. So I'm going to pull that into our middle, our F column. This is going to be this to the power of shift 6 negative 35, and then I'm going to add decimals, home tab number, decimalize it. And so there we have it. If you make it a percent, you can see, maybe some more decimals here. We could bring it out possibly a little further. And so there we have that. And then we're going to say that we're going to do the subtotal, which is going to be the 1 minus that number. So this is going to be 1 minus what we just calculated. And let's add some decimals there. Adding decimals. Okay, and then we have the rate. The rate, which is going to be and I should have pulled this into the outer column, this calculation over here into the outer column. Let's do that over here. I'm going to say this is going to be 1 minus this, and I'll delete this one because I want it over here. And then add decimals here, like so, and then we'll pick up the rate. So the rate is going to be the 10%, so the 10%. So now we have our numerator and denominator that we can then calculate times C. So we got the numerator and denominator, adding a percentage, home tab, numbers, percentify, underline it, home tab, font, underline. I'm going to pull this into the outside now because now I want it in an outer column where we got this multiplication component. This is going to be equal to this, this divided by, numerator divided by the denominator. Add some decimals, home tab, number, decimalize it, and then underline, home tab, font group, underline, and then we can multiply. This is going to be the 60,000 times that number, and there we have it. Let's add a couple decimals there. Home tab, numbers, and add a couple decimals, and that looks good. So we'd have to put in the 578,649.54 to get the 60,000 a year we're thinking at, for 35 years at the discount rate or using the rate of the 10%. So let's go ahead and do that with a annuity formula now. Equals, this is the easy way to do it, equals present value, brackets. We're going to pick up the rate. This is a yearly rate, the 10%, comma, number of periods, 35. This is just like an annuity or a non-annuity kind of present value thing. But now, comma, we're picking up the payments, which are 60,000, which is like an annuity thing, because it would be 0 if it were not an annuity. And then we would do the future value if it was like a thing of 1 instead of an annuity. But it's an annuity, so we're picking that up. And there we have it. It's too big of a number. We're talking too much going on here. And then I'm going to double click on it, go to the front, and then put a negative to flip the sign. So there we have it, done it again in a different way. Let's do it again with tables. We're going to have the 60,000. Pick up the amount on the table down below, which is going to be the 10% and 35 years, which is getting down towards the end of the table. But we still have that one. That's going to be 9, hopefully I got the right one here, 9.6442, 9.6442, 9.6442, 9.6442, 9.6442, percentify it, home tab, and numbers, percentify it, or not, add decimals, I'm not percentifying it, and then home tab, font, underline, and then multiply, so 60,000 times that number that we just said. Add a couple decimals there, home tab, number, decimalize it. And so it's a little bit different than we have here, probably more different than what we've seen in the past. I think it's still right though, but because we're talking about bigger numbers, you get a bigger difference, but it's a little bit, it's still probably immaterial for decision-making purposes. I would expect the rate to be closer to, if we divide this out, the rate would be closer to the 9.644159, and we got 9.6442, which makes it the result a little bit different due to the rounding. Again, because the numbers are larger, that difference will be larger. Also note that book problems could take advantage of that difference, even though the difference is probably not material for decision making. It can be useful for book problems that are trying to force you to use the table or not use the table by making it more exact in the answer key.